Okay, everybody, now I would like to introduce Lars Erik Malmberg from University of Oxford. His talk is Lessons Learned from the Learning Every Lesson study. And Lars started off as a primary school teacher in Finland, and he's now Associate Professor of Quantitative Methods in Education at the Department of Education, University of Oxford, UK. He is Associate Editor of the Journal of Learning and Instruction, and his current research interests are on interpersonal approaches to learning processes and modeling of interpersonal data using multi-level structural equation models. In his talk today, he will present some lessons learned from the Learning Every Lesson study. Thanks, Lars.
Thank you. Welcome all. Welcome also to Jyväskylä and Helsinki and Frankfurt am Main and Constance and in the US, I think, and anyone else who is following the webinar. I think it should be up and running now, and also the PDF versions of the presentations are now available for you, so it will be easier to follow the contents, as I think the screenshot is not that clear. So, lessons learned from the Learning Every Lesson study. I want to talk about a study that started off as more a pilot study for myself during a Research Council's UK fellowship in the UK, an exploratory study that turned out to be quite a good sized study of some 300 students in primary schools in year 5 and 6, and together they responded on 4,500 or so learning experiences. So there is, as we have seen, the reason we have this seminar series, that there's really a growing interest in interpersonal approaches in education. So we investigate educational processes through experiences in real time. This way we minimize the lag between an event and the report of the event. This happens through diaries, experience sampling, ecological momentary assessment, contextual activity sampling systems, and various forms of ambulatory measurement. We do this in order to understand what students' learning processes and experiential processes of learning look like, and once we have understood what the processes themselves may look like, the next step is, as we have seen in the previous talk also, how teachers can support students' learning processes over time. I have sectioned my talk into three parts. The three key messages, I think, coming out of the Learning Every Lesson study. So the large differences within students, so from one time point to another, so there's more variation within students than between, that we want to explain. This justifies the process view itself. We want to understand what explains that within-person variance. The second point is that students experience situational demands and expectations differently. So the question is, how can teachers engage students in the shorter or the longer term, as I will show in the second section. And then perhaps in education, a novel measure on intra-student variability, that is the magnitude of their ups and downs, or their oscillations of experiences throughout the day and working week. So we associate students' teacher-reported task focus with students' interpersonal variability, and this gives us some suggestions for teachers grasping teachable moments, redirection, and trying to refrain from labeling students. The Learning Every Lesson study is about more than 300 students in 16 classrooms in 11 schools, more than 4,500 responses of more than 300 students. Each median response at the time was 1 minute and 49 seconds. Although in this version of device, we didn't have, the device wasn't always stopped at the end of the questionnaire, which gives us a longer upper tail. This is fixed with more modern devices and the timestamps they have. We have slightly more students in year 6 than in year 5, so the students in this study are on average 10.5 years old, slightly more girls than boys, and depending on the analysis, the samples might have different ends. We used a heuristic framework for interpersonal learning experiences, divided into sources of motivation, behavior, outcome, and affect. And the experiences that I will talk on about are the relationship between effort, exertion, and task difficulty, and also intrinsic and extrinsic motivation, and then variability in intrinsic motivation, task difficulty, and competence evaluation. When we start off studies like this, like Barbara said, we work with available measures that are typically used for individual differences between students. So what kind of person are you? Instead of asking them what kind of person you are, we ask about how did they experience the situation. So instead of asking, I'm quite clever, so how well were you doing at this particular task, and how much did you understand of that particular task? So the items are focused on that situations the students are in when they respond to the item, rather than what kind of person they are. We developed a personal digital assistant questionnaire, and we instructed the students. This was a very nice task to teach them, and they got the hang of it in about 30 seconds of median time. And they started asking us, sir, how do we log on to the school Wi-Fi with this device? Can we listen to our MP3 files? And can we play the games on the machines? Which we had tried to hide away very carefully, unsuccessfully, I think. So students were asked to complete a short questionnaire once every learning episode. So there's an event-triggered signal. So after playing guitar for 15 minutes, they would report to us, and then after the final lesson that was part of them would report once again, but at least once per lesson. And they reported first what subject they were doing, and then they wrote in open-ended manner what the task was, which we coded according to curriculum levels, but haven't analyzed here. And then the questions that we analyzed for here. The learning task I was doing was very easy, very hard, so difficulty, and how well were you doing, and how much did you understand? These two items create a competence belief scale. The within-person variability, the within-person variance is explained, showed here. We can see for the blue lines for these 9 sample individual students. The blue lines represent the competence beliefs, and we see that about a fifth of the variance of competence beliefs was between students. More than a quarter was between students, and about a fifth of the variance was between students. So the rest of the variance is indeed from one situation to the other. And we see in these example students that there is a lot of large individual differences in what those patterns look like over time. Now I'll get back to how we can get a measure of how different those are later. But we'll start with 2 example students where we have discrete time, so the time points located on the x-axis and their effort exertion on the y-axis, and we see that these students have the same level of effort exertion across the 20 time points. Exactly the same. I created these sample students. But then when the conditions they're in, the situations they are in, are experienced as different. So we see here that the difficulty patterns that they report are different across time. And when we look there, so Kamal, typically when things get hard, he exerts more effort. And when Sophia gets in a tough spot, she withdraws from exerting effort. And if we take out this time dimension and associate the task difficulty and effort exertion with each other, so here we don't really look at the chronological sequence, but we compare, we use individuals as their own controls. So when Kamal, he increases effort when the task is relatively more difficult for him. This is consistent with ideas that are called mastery approach or self-regulation. And here we see Sophia, she decreases effort when the task is relatively more difficult for her. And this is referred to as a helpless approach in the literature. When we look at all the associations within students between effort and task difficulty, see that those students for whom there's a negative correlation between those efforts and the difficulty levels across the time points, see that the negative correlation is the more difficult the task, the less effort, and positive correlation, the more difficult the task, the more effort was exerted. So there are individual differences in what this association looks like. When we run this as a regression model, we see that each line here in the multi-level model represents one student, and here we also see that some lines clearly go up when difficulty is higher, then effort is higher. For other students, when difficulty is higher, then effort is lower. So the main fixed effect is 0, but there's huge variance around that. And if we then, in the next step, search for, is there a moderator that can explain these individual differences in slopes, we found that high performers, those with higher academic performance, exerted more effort at more difficult tasks, and those students, lower performers, they withdrew effort at more difficult tasks. And that's a neat interaction effect that we're quite proud to find in the data. Conclusions and recommendations for practice that we can think of, that we really, from the point of view of teachers, to recognize each student's highs and lows in effort exertion, and when is the difficulty perception high or low, recognizing which situations these occur, effort, which we also refer to in the literature as on-task behavior, concentration, behavioral engagement. This is something that is observable, while how do teachers deal with non-observable learning experiences like motivation and other perhaps less visible aspects of experiences? And how are other within-person behaviors, beliefs, and perceptions associated over time? So we look at this next example of students' autonomous motivation. This varies by teacher demands and expectations, or the so-called controlled motivation. In this second example, we use the theoretical frame of O'Brien and Deasy of kind of moving scale and fluid scale from intrinsic to extrinsic motivation on a continuum. Most studies so far on intrinsic to extrinsic motivation are either variable approaches or person approaches, where we have cluster analytical technique where we find typical groups of students, and a question asked in one of those person approach studies was, are students switching between two types of motivation at different times? And this is actually the question we're able to answer using the situation-specific measures. So we investigated whether controlled motivation predicted autonomous motivation within and between students, whether controlled motivation differentially predicted autonomous motivation. So the motivation measures were 3 items for intrinsic motivation. Why did you do this task? I enjoyed it, chose to do it, or was interested in it. An extrinsic motivation, I had to do it, or the teacher wanted me to do it. So again, another subsample where we linked this data to 466 teacher reports that were average for each student and student school performance, and then teachers completed one task focus measure for each of the students. So this is a rating of what the student is typically like. It is not a situation-specific measure. It has good construct and structural validity found in previous studies. So in this model, at the within level, we modeled whether controlled motivation, so the extrinsic demands and expectations by teachers as perceived by students, predicting the intrinsic motivation within students and between students, and the direction of those paths are the same at both levels. School performance predicted was positively associated with extrinsic or controlled motivation, which predicted autonomous motivation, which predicted task focus, and performance predicted task focus as we had expected. We then allowed the controlled motivation to vary for each student, that is from one situation to the other, and we included that as a random effect at the between level. What this looks like is that is a cross-level interaction or a moderation effect, which looks like this. So for high performers, their autonomous motivation was not much derailed when teachers' controlled motivation was perceived to be higher. However, for lower performers, that blue line, for these students, when they perceived that teachers' expectations and demands were higher, also their autonomous motivation was higher. So the interesting questions to ask here about these two situations is that, so higher achievers are not derailed in these situations with larger demands placed on them. Lower achievers were motivated during learning experiences. Is this a short-term engagement that teachers need to repeatedly carry out? So each lesson they need to be reminded about the expectations. And the question is, how can this type of extrinsic motivation become more integrated into the self over time, so that it is not something that teachers need to sort of nag about from one situation to the following. Extrinsic motivation will not be integrated into the self if conditions do not facilitate it. We know from other studies that extrinsic demands can be incorporated if teachers are autonomy supportive or instructionally supportive, but not via coercion of the student. How can we support intrinsic motivation without teacher encouragement, support, and engagement? That is probably not possible. The third section of the presentation is on intra-student variability. So notice that I've used two terms. One is the variance and one is the variability. So here we created a measure of the magnitude of the ups and downs. We know from previous studies that there is more variance within than between students, and lower performers seem to have less stable control beliefs over time. So from one time point to the other, the control beliefs move around. Lower performers exert less effort, as we saw in the previous study. And from the research paradigms in psychiatry, where affect variability has been investigated to a large extent, if we borrow that idea, we can look at what does the variability in these beliefs of the learning experiences look like. So the question we ask is, how are teacher perceptions of student task focus related to variability of students' learning experiences? So to do this, we, instead of using the variation within and between, or the mean level change over time, or the stability over time, which is the autoregressive coefficient, or the variation within persons, so an individual variance or standard deviation, we investigated the magnitude of change over time, which is called the mean square successive difference, using this equation with lagged data. So we compare what happens in time point t with time point t plus 1, and add up the differences between those time points. If we look at simulated data, here is intrinsic motivation of the first person, and then in this simulation we just multiply all those values by 2, and then we rank order the observations. So we take out the time dimension and sort them. We look at the behavior of the mean, the standard deviation, the mean square successive difference, and the autocorrelation. So if we multiply the values by 2, we see that the autocorrelation stays the same, so that's correlation between t and t plus 1. We also see that the mean is just scaled by 2, multiplied by a scalar of 2, and the same with the standard deviation. But the mean squared sequential difference really has been affected by the magnitude of those changes. If we then compare the rank order, this with the rank order, we see again that the means and standard deviations stay the same, so the within person variance is the same, but again the mean square successive difference changes dramatically, and so does the autocorrelation coefficient when the date. So here's a large consistency for one time point to the other, but the within person variability is very low, because there are not a lot of ups and downs here, but there are many ups and downs in the first case. So the mean square successive differences seems to be an important way to capture the within person variability in students' learning experiences. So we specified a multi-level structural equation model of latent state, trait, and intra-individual variability, and then we associated trait and variability constructs with teacher-reported task focus. And in the upper part, we see that this is teacher-reported task focus, and their average experience difficulty across the week, negative, so higher task focus, less experience difficulty across the week, higher competence across the week, and higher intrinsic motivation across the week. And for the variability, a higher teacher-reported task focus, there was less variability in perceived difficulty, so less oscillations from one time point to the other. The same with competence, slightly stronger, and this did not reach significance for intrinsic motivation. So using this construct, we found intra-individual variability captured using the mean squared successive differences, which is an alternative metric to use on data like this. It is an aggregate at the between level, but it does capture something else than the trait and the state measures. Teacher-rated engagement predicted trait levels and predicted less variability. So what can we learn from this for the context of learning in classrooms? So all students seem to have their teachable moments because of the oscillations. So of course the task of teachers is to capture those teachable moments when they actually are engaged and motivated for a task and build upon those. Teachers should also refrain from the labeling of students, as all students do have their ups and downs over time. Some have larger swings than others, but this should not result in labeling. The implications for practice. So overall, the interpersonal approach to learning is important for understanding individual differences in students' learning experiences that are not visible in cross-sectional designs, as we have already heard. We should, with findings like this, we should move theories of learning processes closer to actual real-time processes. Many theoretical approaches do talk about processes, but use cross-sectional trait data for evidence. There are implications for practice. Teacher has to individualize and differentiate their instructions. One policy recommendation is a personalized learning, for example, to tailor learning for each individual student. And the question we can also have Catherine Asbury, our discussant today, to help us answer is, do teachers have the conceptual tools for this? Variation from one time point to the other, and within student variability, as I mentioned earlier, teachers can capitalize on teachable moments and refraining from labeling students, as all have their ups and downs. On some consequences for study designs, one way forward could be to have all student self-reports to be fed back to the students on their screens. That would enable self-monitoring, just as people follow their activity levels and heart rates in physical activity, to also have time series data presented to students and see if this could raise self-awareness. Another example from our June seminar proposed by Florian Schmiedek. Students are given individualized encouraging prompts in situations, so small reminders, encouraging messages on their devices while they carry out tasks. This is possible with technology to individualize to a large extent. ABAB designs, we have heard a good example of that in the previous talk. And another design that would be interesting is that all students report on their interaction with their teacher within each time interval. And at the same time, teachers would report on some target students, say 2 high and 2 low achievers. And with this design could actually tell us, are there individual differences between teachers in the way they are responsive to students with various needs. And this study, to the best of my knowledge, hasn't been carried out yet. And I'm not sure I know if anyone has this study in the making. And finally, how can we incorporate biophysiological measures using different timescales like stress activity levels and sleep and the galvanic skin response and the such into designs like this. And I know there's a lot of biophysiological work going on, not that much published yet, but ongoing certainly. I'll skip the statistical techniques. We have some publications out there and more on their way. And thank you so much. How are we doing on time, I guess? A couple of questions, certainly. Yes, please.
So I saw the difficulty of task was also self-reported?
It was also self-reported, yes.
What about the variability on the difficulty for the same task as reported by students? The same task was considered as very difficult for one student and very easy for the others.
Yes, so it is not a teacher rating or an objective rating of the actual task that the students carried out, and neither was it a report of how many different types of tasks students carried out at the same moment in a lesson. So some classrooms, the students would carry out the same tasks in the same order. In other classrooms, there were more differentiated tasks. They have their red booklets and blue booklets and green booklets that they worked on, which are the difficulty or challenge level. This information we do not have, but I think this is something important to build into next studies. Also think that there isn't really a good framework available to actually assess objectively how difficult tasks are by looking at tasks. And I think this is something, another important area to look into. Yeah. Yeah.
Quick question.
Yeah.
Lars. Can you talk us through that SEM, the path diagram that you had, and the interpretation of that? Is that a random slope on the within level? Is that how you've drawn it?
Is it this graph?
No, I think it was earlier.
Okay.
I think it was there.
This
yeah.
one. Okay. So at the within level.
Yeah.
So for we regressed students' autonomous motivation on their controlled motivation, and then we allowed each student's slope to be different from each other. So those slopes would look, I showed you another, I don't have the graph of those two, but the graph would then be something like this. There are large individual differences in those slopes. Mm-hmm. So each line there would be represented by one student. So, and then we went on. That is then represented, this is how it's implemented in the M+ software. And then we predict whether that random slope, where school performance predicts the random slope, and high performance predicts negatively that slope. So you could think of it as kind of slopes as outcome model in the multi-level modeling discussion, or a cross-level interaction between performance and controlled motivation on autonomous motivation. So it's an interaction effect. But it's easier to plot like this here, systematic differences. Okay, how are we doing on time now? What time is it?
It's 5, it's just gone 10 to 11, so should we have a quick coffee?
Yeah, so I think it's time for the coffee break. And let me get my program open.
And you can decide what time we reconvene. We're a little behind.
Yeah, we are a little bit behind. We got a bit delayed in the beginning, so let me open the program and we see if we can get back on track soon. But yeah, sorry, I have it here.